Hello, everyone. Thanks very much for joining us. I'm Dan Bordui. I'm here with Corey Agnew, and we're here today to discuss managing fuels in 2018, storing and dispensing diesel fuel. That's right. We're going to be digging into all things diesel, and this will be the first of hopefully many useful webinars in our series, Managing Fuels in 2018. As I said, this is going to be very diesel specific. We've got a ton of information to cover, and we love and encourage you to submit questions at any time through the web interface here. And our goal is to answer them at the end of the webinar if we have time. Otherwise, rest assured no question will go unanswered, and we'll follow up directly, either Corey or myself, with the answers to your questions. So our purpose here today is to talk diesel and to educate you about what's changed in the market, the problems it's causing, and best practices to help fix and maintain fuel. I am Dan Bordui, the Director of National Partnerships here at Bell Performance. We are very proud to be celebrating 109 years here at Bell Performance. We're named after Robert Bell, our founder, who actually worked back in 1909 with Henry Ford on the Model T. So we go way back. And are proud to deliver a full line of specialized chemical, fuel, and oil treatments that really started, as I said, over 100 years ago with focus on engine performance, essentially, things that helped improve over-the-road vehicles and the performance of engines and fuel-related problems. What that evolved into for us in recent years, probably about 10 years ago, was really into a specialty application of our chemical line into the fuel storage vertical, right? As we know, there's stored fuels all over the place, and all you folks listening have probably a number of different stored fuel tanks, whether they're over-the-road fleet storage tanks or backup power generators. There's a lot of diesel fuel out there these days, and again, several years back, we really started to tweak our chemical formulations to develop a line that was specific to problems and maintaining the quality of those stored fuels. We actually went to the point of creating a unique and specialized division of our company called Bell FTS, which stands for Fuel and Tank Services, again, which utilizes those specialized fuel storage chemicals and also combines that with some other components that we feel are best practices to ongoing fuel storage and maintenance that include testing and analysis, as well as some mechanical cleaning and remediation services, which is why my buddy to my right is here with me, Corey Agnew from Guardian Fueling Technologies.
Thank you, sir. Yes, my name is Corey Agnew. I'm Director of Fuel Quality of the FuelGuard division for Guardian Fueling Technologies. Guardian is located in the southeast and mid-Atlantic of the United States, and we provide full construction, sales, service, and compliance of petroleum systems. A few years back, with the advent of ethanol-blended gasoline and ultra-low sulfur diesel, Guardian service technicians saw an increase in service calls related to corrosion, slow flow, clogged filters, issues with meters and leak detectors, and as a result, the FuelGuard division was created specifically to address these, address correcting the contaminated fuel issues that really is the root cause of a lot of these mechanical service calls, which we'll discuss more throughout the presentation. So we'll take it back to Dan here.
So again, today we're digging into diesel fuel contamination, and we're going to share with you our experience and expertise, right? What Corey and I have come across over the years in the real world, right, and out in the field. And you know, we've also combined that with some guidelines and best practices from our industry leading organizations, like you see there in our little logo soup on the slide. And some of the things specifically that we drilled down into and used as a cross-reference for our webinar today were things like the Battelle report from 2012, corrosion in systems storing and dispensing ultra-low sulfur diesel, the Steel Tank Institute's R111 from 2016 for recommended practice for storage tank maintenance, PEI RP 900 from 2017, which is a diesel fuel technical review. You've got the Chevron 2007 diesel fuel technical review. as well as EPA's pretty well-known 2016 investigation into advanced corrosion in USTs, and our friends over at ASTM and D975, which of course I'm sure everyone knows is the standard specification for diesel fuel oils. So what we really wanted to try to do is streamline everything down for you. Again, we know there's a lot of information out there, and our goal is to just help decipher that, streamline everything down, and we really focused things on three fundamental components related to diesel contamination and the storing and dispensing of fuel, which is these three fundamental things, right? They are why contamination occurs, right? The effects of contamination, and best practices for remediation and prevention. So at the end of the day, the fundamental truth is this: diesel fuel is not what it used to be, and ongoing fuel quality management is essential. So let's dig into the why. Really, there's five, again, fundamentals or main reasons that contamination occurs. They are quality of crude, the advanced refining processes that are happening at the refineries, government regulation. More than ever, we deal with that today, and things like the advent of ULSD, or ultra low sulfur diesel, water intrusion, and another factor into the contamination equation, and finally the introduction of biodiesel. So what does all this lead to? Fuel system contamination, right? And again, at the end of the day, for end users like everyone listening in our audience, diesel of old, essentially maintenance free for 5, 6, 7 years sometimes. While today, common practice and belief will tell you that you're lucky to get 6 months to a year. So let's dig into each of these in a little more detail, and we'll talk about the quality of crude oil. So right out of the ground, crude is not what it used to be. It's ever changing, and depending on the crude stock, you're just going to get different variations in the base crude. Different geographies, are organically going to provide different compositions of crude, and coupled with the simple supply and demand, realities of supply and demand that are out there, this leaves us with a fuel that's not only different in its fundamental chemistry, but it also requires a new level of care and maintenance. So what are they doing at the refinery that's contributing to this, right? What's the goal of a refinery, right? It's to produce the best product they can and the most product they can at the lowest cost, right? They're for-profit business, and that is their objective. And of course, they're held to the legal standard of D975. So that essentially is their goal. Now, with amped up demand and increased production, they've also advanced their processes and implemented things, and you may have heard these terms of hydro-treating or hydro-cracking, right, which essentially allows these refineries to produce more product, but unfortunately that product isn't necessarily as stable as it used to be, and I think we can all agree, and probably why we're tuned in today, it's certainly more problematic than it used to be. One of the things I think is worth talking about relative to D975, while it is in fact the specification and the legal requirements essentially of diesel fuel, and is absolutely necessary for the production of diesel fuel, it doesn't necessarily speak to all the things necessary to maintaining the fuel. So we'll talk more about that to come, but bottom line, diesel fuel starts deteriorating immediately after leaving the refinery. It's produced to spec, but once it's out of the gate and in the pipeline to the end user, things start to happen, and the responsibilities for managing those fuels ultimately fall on you guys, the end user. So, in addition to the advanced refining processes, good old government regulation. It's a part of life with everything we do, and fuel has not been excluded from that. So, initially as part of the Clean Air Act, which was good for the environment, they looked to remove sulfur from diesel fuel, which contributed to acid rain, and again was a good thing for the environment. However, not necessarily so good for the fuel and more importantly the equipment that utilizes that fuel. We went from 5,000 parts per million, or what they call high sulfur diesel back in the day, to really 2006, they really started clamping down and moved to a 500 part per million, or what we call low sulfur diesel, and then today that changed to 15 parts per million, or what we now know as ULSD, or ultra low sulfur diesel. And the handwriting on the wall just may continue even further to where sulfur is maybe even completely phased out of the component of diesel fuel. So they did it for good reasons, but it had unintended bad effects. And one of the things that kind of came out of that was the process of removing the sulfur also removes components that are, kind of previously acted as a natural biocide, right? Everyone, I'm sure, is hearing a lot about microbial growth, and that's certainly one of the things we're going to talk about in more detail today. But when they had high contents of sulfur and they weren't going through the process of removing that sulfur, it allowed for a chemistry within the fuel that acted as a natural biocide and kept those things like microbial growth at bay. So, what this information really means practically is that, ULSD is kind of guaranteed to become contaminated if you don't employ proper management, and control what's going on within the fuel. So, we've covered the advanced refining process. We talked about the advent of ULSD. Now let's talk about water for just a minute. And I'm going to hand it over to Corey to talk about this third component.
Water intrusion in tanks is not a new issue. All tanks accumulate water over time. The only thing that's new is the ultra-low sulfur diesel that we're using now. So microbial growth occurs when you have water in ultra-low sulfur diesel. Mm-hmm. To explain a little bit further, a drop of water is like a lake to microbes, and when you have water and fuel, life occurs. Those microbes live in the water. They use diesel as a food source, as well as trace amounts of ethanol that's present from deliveries. The bacteria then excrete acids which compound contamination issues. So let's talk about how the fuel gets into how the water gets into the fuel in the first place. Part of the issue is that water is coming in from the refineries. Production of the refineries has sped up to the point where water doesn't have time to settle out like it once did, and those refineries pass that burden on to the end users. We also just talked a minute ago about the hydrodesulfurization process that's used to remove sulfur. One of the byproducts is the creation of additional paraffins, which enable the fuel to attract and hold more water. Those paraffins also compound the issue by causing fuel gelling problems in the winter, like a lot of people in the north are dealing with right now. Tanks naturally take on water anyway. They do this through condensation. And when there is a component missing as well, such as a fill cap removed or gaskets that are cracked or sealed, water can get in the tank through those ways as well. So here's some examples of what we actually see in the field when we sample the tank bottom. These are all samples that our technicians have collected from diesel fuel tanks. You can see the interface of the water on the bottom and the diesel fuel on top. And what you have in the middle is called the rag layer, which is where a lot of the microbial growth occurs. However, you will have different microbes in the diesel fuel and in the water. So now that we've talked about water intrusion in tanks, we'll talk about the last culprit of contamination, which is the advent of biodiesel. So all diesel fuel now can contain up to a 5% blend of biodiesel without requiring labeling or notification from the supplier. So to put that in perspective, a 10,000 gallon tank means you could have up to 500 gallons of biodiesel. That biodiesel comes, it's a lot of biodiesel. And that biodiesel comes from different feedstocks, and all those feedstocks react differently with water and with microbial growth as well. And specific to the chemistry of biodiesel, biodiesel retains water very easily, making it difficult for breaking the bond between the water and the biodiesel itself. So in general, everything bad that we know about diesel fuel is compounded by adding biodiesel. And so now that we've reviewed biodiesel, we'll talk a little bit about the effects of the contamination on your fuel system and what you'll see.
So thanks, Corey. I appreciate it. So we covered the why, right? And what's the takeaway? The takeaway is that diesel fuel is not what it used to be, right? And contamination, unfortunately, guys, it's here to stay. You know what else isn't what it used to be, Corey?
What?
The effects that it has on the folks that rely on this stuff and that store the diesel fuel. So let's get into the effects, right? Before we jump in, to the specifics of the effects, I wanted to just kind of frame up some fundamental distinctions or categorizations so we can put this in context here for our presentation today and how we're going to kind of be bucketing things today, right? So you can kind of look at this in two fundamental ways. There's what we call fleet applications, right? High turnover fuels, right? And things that are actually going to be, fuel that's going to be coming out of a fuel dispenser. There you go. Yep. And then there's backup power, right? Or low turnover fuel, right? Those backup generator sets that we know are all over the place and storage, that's right. And fuel tends to sit, right, for extended periods of time. So again, just wanted to put that in a little context for you. And then let's take a look at the effects, related to diesel engines in general, and then we'll also talk about considerations for backup power. So do any of these sound familiar to you guys, right? I mean, fuel filter plugging, right? Combustion chamber deposits, lacquering of injection system components and valves, excessive soot in your DP filters, right? That coat your engine and cause you to limp back into the shop. Reduce power, greater wear, on your engine components due to particulate, reduced fuel economy, and ultimately failure, right? These recent storms that we went through here in the Southeast, were rampant with power failures and backup generators. At the end of the day, newer engines don't tolerate contamination like they used to.
That's right. The new Tier 4 engines, they're engineered so precisely that a lot of them have injector issues whenever they have a small amount of water or particulate in them. So they're just much more sensitive than what the old diesel engines used to be.
That's right. And at 30 to 40,000 PSI, on the high pressure common rails, you pass a small piece of particulate can become pretty abrasive and pretty destructive. And rest assured, guys, again, you're not alone out there, right? We're hearing this across the board, and all the customers we deal with
very common
in a lot of different industries. But specific to backup power, at least, some of these issues with contamination really are more perilous or more dangerous for these mission critical type backup generators. So, now I'll kind of kick it back to Corey, to the dispenser side,
let's
right?
See what happens in storage tanks and dispensers. So, effects on tanks and dispensers. We'll see slow flow, clogged filters, frequent filter change, bad check valves, issues with leak detectors and meters, advanced tank corrosion. For the retail stations, what they see is more service calls, spending more money on fixing components of the system, slow pumps, and dissatisfied customers. This is very common for what the Guardian technicians see.
One of the things, that I just wanted to drill down a little bit deeper into, and probably deserves its own webinar actually, given there's so much information, but the corrosion problem, right? That's one of the things we probably hear the most, right, Corey, from customers that were responding to service calls on plug fuel filters, right? Yep. And corrosion. And just real quickly, a preface or some backdrop on why there's such a rampant corrosion problem these days, is really related directly to the micro problem that we kind of touched on, and what they call MIC, or microbe-induced corrosion, right? And essentially, what happens is, these microbes are living organisms, as you talked about in the water slide. They're living, they're breathing, and they produce byproducts, which are acidic in nature. And again, in real simple terms, some of these byproducts are heavier than the fuel that they live in, so they'll kind of stay in suspension, or they'll drop to the bottom, right, and cause corrosion and pitting, right, in the bottom of the tank by turning the fuel itself acidic, right, to lower the pH, or make the fuel, more acidic. And some of these byproducts are a little bit lighter than diesel fuel itself. So what happens is they evaporate, and they'll combine with the moisture that we talked about, condensation, right? We always know there's moisture in the vapor space. They combine with that, and guess what? Now you've got highly acidic vapor, right, above the fuel line, or what we call vapor space corrosion, right? It'll corrode things. Absolutely, it'll corrode the steel on the tank above, and also things like your sump tubes, right, and the turbine pumps, right? You see a lot of that in the retail setting.
We'll get into that in the next few slides too. I've got lots of photos of that.
All right, so and that's great. Let's take a look at some more of the specifics from the field. And Corey, you want to talk a little bit about what these are?
These are some photos of what our technicians see in the field. On the left, that you can't really tell what it is, but it is an STP, submersible turbine pump, clogged with microbial growth. On the right is a filter, dispenser filter. What I noted on that was the amount of corrosion in there. These filters are changed fairly often, and the corrosion happens very quickly. So this is very common for what our technicians see in the field. The next slide here is a leak detector and corrosion seen on that. These are all costly components that need to be changed out often due to this microbial growth and the acid that's caused from the microbes.
Yeah, this one on the left here is a great example of microbial, contamination, clogging filters, and again, they proliferate so quickly. It doesn't take long for a few microbes to turn into a few 100,000 colonies,
right?
And make a mess out of it.
Exponential growth.
Absolutely, and so it can happen quick, and obviously a fuel filter looks like that, your engine's not going to stay running very long, right? On the right, you see this is actually a bag filter from one of our filtration carts in the field, right, Corey?
Yeah, these are, this is something called asphaltene agglomeration. It's actually just a breakdown product of the diesel fuel itself. So it doesn't have anything specifically to do with microbial growth, but as diesel fuel sits in a tank unused over time, those hydrocarbon chains will break down, and they kind of form this tarry, coffee ground-like substance on the bottom of the tank, which is something that we commonly remove from the tanks.
Here's a good pic of those microbes we talked about, right? It kind of looks like something you might get at a low-end fast food restaurant, but don't order it, and certainly don't eat it. And Corey, you mentioned just a second ago, look how quickly those multiply, right? One cell, it can become 246,000 in 6 hours. So at the end of the day, like I said, these things, they attack, and when they do, they attack quickly. And you want to steer clear of them. But these are, again, real pictures of things we found in real tanks out there in the world.
This stuff is in tanks. We see it all the time. These pictures are of a STP being pulled from a tank. On the left, you can see the microbial growth and corrosion. On the right, you can see how the STP is just completely coated with microbial growth. And this is par for the course in what is on the inside of diesel tanks these days, that specifically with diesel tanks that don't have any fuel maintenance program at all. This tank here, this was a removed tank where you can see corrosion over time from that acetic acid and other acids in general. They will just eat away at the metal very quickly.
Hopefully your tanks don't look anything like this, but unfortunately for some folks they do. And I think the question that hopefully this is posing to you, and that I think you absolutely have to consider, is what impact does this have on your day-to-day operations? I mean, what would a tank like this mean, to you and your operations? What are the costs to your organization? The dollars and cents of this. I mean, when you consider things like downtime for repairs, right? The capital expenditures, that go along with replacing, tanks like this. I mean, tanks are not cheap, right?
Right.
Hundreds of thousands of dollars in some cases. Loss of customers, right? It takes so much to acquire a customer these days and keep them loyal. That's the last thing I think any business can do is afford to lose customers.
And granted, this is likely a single wall tank, and a lot of people have double wall tanks now. However, you don't want to go from the interior of one tank to your double wall tank. The whole purpose is to retain, you want to make sure that you're not having any environmental spills from the corrosion breaking through the tanks, but you also want to retain your equipment and your assets and make sure that that whatever you're purchasing, your tanks, the system components, that they're going to last as long as they possibly can.
Absolutely, and that's a liability, a hard liability. And when you look at some of the other industries that are out there that are more mission critical, like data centers, right, where we've learned and heard numbers like $9,000 per minute that they're offline, right? That's the cost to some of these data centers, right?
Hospitals.
Emergency services, EOC centers, police, fire department, hospitals, and healthcare, where it is truly life or death, right? I mean, something you definitely got to pay attention to, and there's a lot on the line. So hopefully, you know, it's good to think about, and don't worry, you know, the situation's manageable. So it's not a scare tactic here, but you know, we definitely should be
the reality of the situation.
It's the reality.
If not managed, these issues are going to end up.
That's right. So it is manageable. So let's talk about how to do that. So again, we've covered the why and the effects, and again, what's the takeaway? Diesel fuel is not what it used to be, and contamination, unfortunately, is here to stay, and they are causing very real and very painful and expensive problems right across many industries, like we just saw. But again, there's a light at the end of the tunnel, so never fear. So now we're gonna transition into you know, best practices, right? What are the things that again, in our opinion, in our experience, in our expertise, and cross-referenced again, like we mentioned earlier in the presentation with those organizations and associations, you know, what are the best practices? But before we jump into specifics, wanted to frame this up a little bit and have some fundamental distinctions that you've got to consider when taking in best practices, right? So there's initial treatment, right, which is essentially kind of think of that like resetting, right, baselining, getting to zero, right, or maybe in the case you've got a brand new tank, right, you need obviously the baseline from the get-go, right? So you've got initial treatment versus ongoing maintenance, right? And by ongoing maintenance, we mean ensure that contamination doesn't build up, right? To impacting operations, right? You've gone through the process of initial treatment, and now you want to get into a maintenance program, right? And you know, from a cost perspective, there's always going to be higher costs on the front end with the treatment. You know, maintenance, it gets way more cost effective, and at the end of the day, I think everyone will agree it's always more cost effective to prevent a problem than it is to fix it.
And there are some things that everybody can do for themselves on site. We'll get into that a little bit more, but some activities also you'll need to get a service partner to help you with.
Absolutely, and those are the two final quadrants, right? What can you do yourself? As Corey said, there are definitely things you could and should be doing yourself, but there are times where, you know, service partners are required to bring in or at least consult, right, to get some expertise. So again, we're going to be drilling down into three fundamental components related to how to deal with diesel fuel contamination, and specifically our thoughts on best practices. And they are sampling and testing, right, both in field and laboratory.
Which is understanding the amount of contamination and what the chemistry of your fuel is at the moment that you need to clean it or assess it.
That's right, right? Give us the benefit of a clearly defined problem, right? So we know what you're dealing with. Absolutely. So we can make recommendations and, you know, solutions, right? Which typically, you know, involve a couple different things. There's mechanical processes of tank cleaning, right, and fuel filtration, right? And there's also an important distinction I think we should draw there. There is a difference. Sometimes they're looped or lumped together, and you know, people will call them fuel polishing, right, or again tank cleaning. But the reality is they're really two specific things. There's cleaning the tank itself, and then there's a process of fuel filtering the fuel and cleaning the fuel.
There's a variety of ways to remove contamination.
Absolutely, and we're going to touch on those in a little more detail in just a second. And then the third component, right, to this process is chemical fuel treatment. And again, the idea is you sample and assess, give yourself the benefit of a clearly defined problem. We can then make treatment recommendations that involve some type of mechanical tank cleaning and or fuel filtration that's supported and augmented with chemical fuel treatment. And then it's kind of a wash, rinse, and repeat. You return to, you know, more sampling and analysis, and you base your action and treatment protocols from what you find in the analysis, you know, sampling and analysis side of the equation. So let's dive in a little bit more on sampling and testing, and you know, we'll let Corey talk a little bit about that and some of the things they do in the field with regard to the initial assessment.
So when we send technicians out into the field, we first assess the fuel in a few different ways. One is we collect a tank bottom sample. On the left is a picture of what we call a bacon bomb. It's a tank bottom sampling device. You drop it down into the tank, and there's a pin that when it hits the bottom, the pin displaces and allows fuel and water, whatever's on the tank bottom, to go be captured in the device. That's how we collect all the samples that you saw in the previous slides. We also stick the tanks with water detecting paste and get a tank monitoring printout. We compare the information that we get from all three in order to really try to assess and understand what's going on in the tank and the amount of contamination that we're dealing with. Another option that we have in the field, and this is useful specifically for generators and diesel fuel that sits for a long time, but this is a Zeltex device. It will measure both octane in gasoline and cetane in diesel fuel. Again, for diesel fuel specifically, it's most useful for generators because that's fuel that sits for very long periods of time, degrades over time. This is a tool that we use in order to understand if the cetane level has dropped based off of degradation of the fuel.
And just to talk a little bit more about cetane and its importance related to diesel fuel, essentially it's gasoline's equivalent of octane, right? It works in a little different way, and without getting too far into the weeds, they do serve the same function, which is to provide detonation at the right time, right? So that essentially you're getting full combustion, you're getting full downstroke of the piston, full power, and again, no incomplete burn, no incomplete combustion, and negative things like soot and particulate damage. Also really helpful with starting issues, especially in cold weather, again, which can be important for fleets, but certainly particularly important, as you said, for backup generators, right? When those things, if starting's a problem, it's related to backup power.
It's either not going to fire or it's going to damage the engine if the cetane's off.
That's right. Microbial tests are another thing, again, that really have become kind of a must-do, in our opinion, and again, best practices across all those great organizations and associations we talked about.
It's a great way to assess the fuel contamination, to understand if you've got microbial growth in it.
So these are some basic in-field culture tests, essentially, and there's some variation in the three. What you see on the far left is kind of a very basic agar dip slide that will again show you, a basic again pass-fail. Do you have a problem? Yes or no? Is it bacteria? Is it fungi, yeast, or mold? And just gives you a very basic understanding of what type of microbial contamination you have. And again, it's more of a pass-fail scenario, as is the center picture, which is more of a liquid medium. Gives you a little better output, but essentially telling you the same thing. Do you have microbes or don't you? And then there's also specialty gels that you can get into. And again, all good practice, things you can and should be doing, things we certainly use out in the field to start to understand and get our heads around, all things microbial. The other component when you talk about testing, right, is lab analysis. I'm sure all of you are aware there's a lot of different labs that are out there, and this can be used to verify that treatment has been done properly, right? That your fuel is in spec and that you're compliant, right? In some cases, some industries demand that, right? Certainly, we know in hospitals and healthcare they have to have reports like this or have to have tests like this run and reporting done so that they can show that they're compliant and their fuel is in spec.
Because there's regulatory oversight.
That's right. And again, just a reminder, we touched on this before, D975 is the spec for fuel to show that, yes, this is in spec, but it's necessary for the production of diesel fuel, but it doesn't necessarily speak to all the things necessary for maintaining the fuel. So while, again, this is definitely best practice, and lab analysis, again, is something we use as part of our protocol and our suite of services, if you will. The thing you want to do is consult and design a battery of tests that are really going to be specific to your application, right? And that are going to give you the type of reporting elements that you need. There are a couple things I want to talk about with regard to sampling and testing, just to put some things into perspective. Just, like everything else out there, ASTM has a standard for fuel sampling and handling, and it's extremely important that you employ the ASTM protocol. Things like tank and fuel water measurements, the proper techniques for sample 1, cleaning the sampler, proper techniques for sample 2, who knew that there were actually 2 samples that were supposed to be taken, containment and labeling, and in packaging and transportation for the tests themselves. And at the end of the day, again, I say this because sampling is hugely important, right? And the testing that you run is performed on those samples. So at the end of the day, if your sampling process and protocol isn't done properly, you're not going to get valid results. That's right. Your test results aren't really valid. So it's extremely important that you follow the right protocol or partner with someone that utilizes the proper sampling techniques. The other component to this is handling, right? Also part of this is once you pulled the sample the right way, it's making sure that you handle it, for example, putting the sample on ice while you're transporting it for shipment to said lab. So both of these things are hugely important. Again, we use them in the field and suggest that our folks should employ them as well or partner with folks that do. Another just quick point of reference and kind of speaks to this is chain of custody. So again, this is a large form that shows a lot of different information, but the takeaway here is that samples really should always come with a chain of custody that shows things like when they were taken, who pulled the samples, and the things that were done to them. And any laboratory or really any company that's involved in testing that's worth their salt is going to have and should have proper chain of custody. Again, the chain of custody document,
it's kind of like the final piece of the puzzle for all the assessment and understanding what's going on with the contamination in your fuel.
So now we'll move into the mechanical side of tank cleaning and fuel filtration. And as we said, remember, there is a difference.
Right.
So Corey, I'll throw it back to you and let you talk about all things mechanical.
So when removing contamination, there is a spectrum of services that are available. The quickest, lowest cost option is a bottom sweep. There's time and place for that. On the other end of the spectrum is, full confined space entry, which is arguably the most expensive, most labor intensive, most equipment, but time and a place for that as well. It's important that you have a good assessment of what's going on with your contamination in order to figure out what the best service is for you. Between those, the bottom sweep and the confined space entry is in-tank filtration. So we'll go through each one of these services here briefly. On the in-tank filtration, the bottom sweep, here's a photo. What you want to do is you want to make sure that you access all ports, pull the probe, the STP, and the fill. You want to find the bottom of the tank because that's where the water and contamination is going to lie. And what this is it's just pumping off the water and the sludge that's accumulated in the bottom of the tank for disposal off-site. It's very quick. It does not address microbial growth. And usually is just intended for tanks that have been cleaned, they've been on a maintenance program, but they just have a small amount of water accumulated in them. And they need, an ongoing spot cleaning for ongoing maintenance. Now, for in-tank filtration, we do the same thing. We measure and assess, we remove the water and the sludge, but we also add chemical treatment and filtration to this. The filtration has a few components. It's on the water removal side, we've got coalescers and water absorbing filters to pull out all the suspended water from the fuel. We've got bag filters that remove particulate down to 5 microns. Fuel is typically delivered at 30 microns, so this is a little bit of overkill, but it's useful to remove all the particulate. The chemical application is very important in this stage too, because that's what helps kill everything in the tank. And the in-tank filtration we use to agitate and stir up all of the contamination, and then it's our filters that recover all of that. So it's a few steps above and beyond what a tank bottom sweep is.
And we'll talk a little more about chemicals in just a second, but
Yes.
I just always love to stress that point, right? That,
Right.
that
Necessary.
the application is equally as important as the chemicals themselves, right. and it's absolutely part of the process to introduce them at the right time, right. in the process.
And so with in-tank filtration, what we do is we use a series of sight glasses and pressure gauges to understand how much contamination we're actually recovering at the time, and how the process throughout the day is actually, how well it's working for removing the contamination. We've got a short video here that we can watch. You can play that. Let's see. And this is us removing contamination through our sight glass. You can see as we hit different pockets of contamination, there's inevitably rust particles in there, but also pockets of sludge, water, microbial growth.
That's amazing, right? I mean, to see that level of contamination, and that's right. Standard though, right?
Yep, throughout the whole bottom of the tank, growing on the sidewalls of the tank as well. And that's where really the agitation, the chemicals, killing the bacteria, killing the microbes, and then agitating with the, that's all right, we'll get it, agitating to help remove that contamination. This next slide is the opposite end of the spectrum, confined space entry cleaning. When we actually get somebody into a tank, what you would do here is we remove all the fuel from the tank, you put it in a holding tank. You actually get guys inside to remove the contamination from the sidewalls. What's interesting about this photo is you can see the level kind of midway through the tank where the typical, that's where the typical fuel level was held in this tank. But if you also look a little bit down towards the bottom of the tank, you can see that's where that tank bottom corrosion is. It's kind of a line going all the way through. This is a 15,000 gallon AST. This is really useful. The confined space entry is most useful for tanks that have never had a cleaning. You know, you've had multiple mechanical issues that have kind of just built up over time. This is the most useful way to reset a tank to zero, especially a tank that has significant amounts of contamination. So now that we've reviewed a few different ways to remove contamination from the system, we'll talk a little bit about applying the chemical treatment.
Thanks, Corey. So, as Corey mentioned, you know, chemical application is the third, you know, head to this monster, if you will, and certainly equally important, right? As we touched on earlier, there are things that chemicals can do that the mechanical components can't, and vice versa. So, at the end of the day, again, it's from an engine performance and tank storage perspective, it's a very necessary component. And again, there's things one can do that the others can't. And they also serve to augment the mechanical processes, right? Essentially making things like water and sludge removal or fuel filtration more effective, right? So that's one of the things that's important to consider, not only that, you know, the chemicals do what they say they're going to do, but they're also engineered for, you know, the process of maintaining and cleaning a tank, whatever that means. You know,
supplementing what the refinery isn't giving you.
Absolutely.
Isn't obligated to give you.
Absolutely. And I always like to use the analogy of baking a cake, right? If you can have all the right ingredients, but if you don't follow the recipe, you're probably not going to get the cake that you want. And it's not going to turn out the right way. So let's talk in a little more detail about, again, some of the actual chemistries that we use in the field and that we recommend as part of any sound, you know, practice for cleaning tanks and maintenance programs. And again, they're going to be specific, you know, in some cases for engine performance, right, or things that have benefit to fleet. And then there's going to be some that are going to be more specific to just in general tank storage. So in general, when we talk about tank storage, two chemicals and chemical packages that we feel are an absolute must are biocides and biomass dispersants. So biocides, I mean, if you look at the recent EPA study that we referenced, that is one of the absolute must-have. When you have a microbial infection, the only thing that is going to effectively kill that infection is a biocide. Biocides are heavily regulated, so you want to make sure that you're partnering with a company that has all its EPA registrations in place and has all the proper, again, registrations and approvals in place from the EPA that one, they're as chemically similar to fuel as possible, and also that they're not going to harm the equipment in which they were intended and designed to run. And that really speaks not only to biocides, but just in general to fuel treatments and fuel additives. You always want to make sure that's true. In addition to biocides, we talked about biomass dispersants. This is something that we actually uncovered in the field and developed accordingly with a customer that we were having that was a generator dealer. And they were, having problems. We're using biocides, but we're having problems with reinfection of the tanks and couldn't quite figure out why. Well, after some R&D and some conversations with this customer, what we figured out was that they were having significant biomass problems. And by biomass, what we mean is agglomerations of individual microbes. Individual microbes form colonies. These colonies form large
pockets, right?
Pockets, absolutely. And some of those fast food items we saw earlier, those nasty looking clumps of biomass, right? And the problem is that sometimes biocides have a hard time penetrating those biomass. Think of it like a bulletproof vest. They form a chemical matrix that essentially the biocide is incapable of penetrating, so you need something that can break that up, disperse that biomass, so that the biocide can get in there and kill and get rid of those nasty micro problems. So in addition to biocides and sludge or biomass dispersants, we also like to utilize, and also recommended by the EPA, are corrosion inhibitors that essentially put a barrier between the fuel and the tank itself to inhibit corrosion. Water demulsifiers are very common when we talk about, just general fuel storage application. These are things, that help drop the water to the bottom of the tank so that you can wring out any water that's emulsified up in the fuel and could create potential problems in your engine, and some of the things we talked about in the high pressure common rail injection systems. It also, again, aids in the mechanical remediation process, right? And again, specifically effective for the new high-pressure common rails that really don't want any water pulled up into the system, and you want to wring that system clean, essentially, of water. Absolutely. Stabilizers. That's the other thing that's kind of the third component in a general sense. And with a good quality stabilizer, you can expect an increase in stability of the fuel by as much as 4 times versus untreated diesel fuel. We talked a little bit earlier about cetane, right? And cetane improvers are also something that are important to consider and can be dealt with from an additive perspective, and are important both in backup but also have benefit for over-the-road applications because those same problems with having cetane deficiency or improper cetane numbers in your fuel can lead to a number of vehicular problems for any fleet vehicles. Things like, again, contamination on the injector tips and fouling of those type components, as well as EGR valves that control fuel-air ratio, and excessive particulate in diesel particulate filters, things of that nature. So other things that have added benefit for engine performance and over-the-road applications are lubricity. Although bio has helped at some level to restore some of the lubricity that the removal of sulfur created, there are still times when additional lubrication is required to protect some of those moving parts that are exposed to the fuel. And then detergent packages, hugely important for deposit removal, again, on some of those key components like injectors and valves that we talked about. And again, just to reiterate, best practice is to always choose chemical formulations that are specifically designed for long-term fuel storage applications, right? And also that are designed to work in combination with, those mechanical tank cleaning and fuel filtration practices that Corey just outlined. Again, we talked about making sure they're EPA registered and approved, commercial grade industrial strength, which means concentrated, and have concentrated treat ratios that are going to be effective to treat the problem and also give you the best bang for your buck from a purchasing standpoint. And then again, components of biodiesel, right, in fuel, making sure that you have additives when they're required, right, that are biodiesel specific and are engineered specifically for biodiesel. So at the end of the day, choose the right chemical package for application, whether it's fleet, whether it's backup power. And again, that's just kind of a backdrop on all things chemical and how it relates to the overall process.
And I just want to touch on what you said about using this in conjunction with mechanical tank cleaning and fuel filtering. We've had, I've talked with people before who have just used chemical additives, and what I just want to stress is it doesn't necessarily make contamination disappear. It can prevent it from occurring, but if you have a contaminated tank or you have microbial growth and you're adding biocide, you've got to get rid of it somehow as well. So we have to use those things in conjunction with each other.
All right, so we're moving swiftly and nearing the end. So just wanted to touch on some of the reporting components that, again, should be sought after and looked for from a partner, or again, that you should try to develop as part of your own, program, right? So for your records, right, we always want to retain documents related to the fuel maintenance, essentially trying to provide a story, right, of what's found and the summary of activities that's been conducted by technicians, whether it's, again, an outsourced partner or, your own folks performing the operations, right? We really try to provide our clients with a clear understanding of what's happened, and the recommendations made, by ourselves and what the technicians did in the field related to the entire petroleum system,
and
essentially.
It's good to have a history, too, because at some point, the fuel maintenance program is going to be an ongoing thing. You don't just do it once and forget it. You will have a maintenance plan for the eternity of having a fuel system that you're using, storing, dispensing. But having these records is really important too, because if there's ever an issue, you can go back and see how much fuel was in the tank when you added such and such chemical, or how much contamination was removed. Inevitably, something breaks, and it's good to have this as a reference point. So whatever you do related to fuel, make sure that you have those records, you retain them. You've got a good history of what's going on.
It reminds me of that adage, right? Sometimes to see where you're going, you have to know where you have to know where you've been. That's right. Which is a great segue into kind of getting into our wrap up here, right? What do we cover today? We covered what's changed in diesel fuel, the effects that it's created for the end users, and how to fix and avoid them in the future. So while diesel fuel is not what it used to be, and the contamination's here to stay, and we certainly know they're causing all kinds of very real, very painful, very expensive problems out there across all industries, there is a light at the end of the tunnel. We are here to help, and we'll just finish here with a couple things that you can do and should be thinking about with regard to coming up with a best practice and a program for dealing with diesel fuel contamination.
So there are some things that you can do yourself out on site. Stick your tanks monthly with water detecting paste. If you have a method of sampling the bottom of the tank as well, sample it every month. Whenever there's water, get rid of it. Water is the enemy. There should be a zero tolerance policy for water, because that really is the catalyst that starts a lot of the cascade of issues. Visually look at your tank system. Look at entry points where water intrusion can occur. Sumps with water in them, fill caps that may not be tight, or make sure there's gaskets on fill caps. You can also, if you're not storing diesel for long term, like in a generator, and you have, let's say, a fleet where you have regular deliveries, if you control your inventory, the quicker you turn your tanks over, meaning emptying them, filling them back up, emptying them, filling them back up, there's less time for contamination to build up. So if you have a higher turnover of your tanks, that's going to help you as well. Look for signs of corrosion of your components, and contact professionals if you suspect that there's any water intrusion or corrosion issues. Long term, you need to plan on having a fuel maintenance plan. This is not a problem that you can't ignore. Should you choose to ignore it, we'll end up having issues.
And budget for it, right, Corey?
Right, absolutely.
You see that all the time, right? Folks are aware of the problem. They know they need to do something about it, but
creeps up to the point where something's broken and then it's an emergency.
That's right. That's right. They don't have the dollars to fix it. So be thinking ahead of the curve and be thinking about, from year to year what you need to budget for.
Right. Implement monitoring and testing protocol, making sure that you're assessing and understanding any level of contamination that may or may not be in your tank. Again, chemical additive package is crucial because the fuel coming from the refineries is not meant to make your engines perform better. It's not meant to have a shelf life over 6 months. Chemical additive package really helps to correct these issues, stabilize fuel, prevent corrosion. We recommend at an optimum adding biocide quarterly in conjunction with, at minimum, an annual filtration and removal of all water and particulate. Some facilities that are mission critical will do that twice a year, but at minimum annually.
All right, so those were some of our recommendations, and as we've talked about repeatedly, we've tapped into a lot of different resources from organizations and associations to help, again, with the information you saw today and help streamline things for you. And this is just a quick example of, the EPA report that focused on the investigation of corrosion influencing factors in underground storage tanks, the takeaways there. From a standpoint of cause, effect, and best practices. We've also got several other reports. Again, we talked about this very early on. The Battelle report, Steel Tank Institute has some wonderful information on recommended practices for storage tank maintenance. Our friends at ASTM, Chevron and their diesel fuel technical review, and of course PEI and RP 900 with their diesel fuel technical review. So at the end of the day, these are the things we reference, and we're happy to share with you.
We're not the only ones working on this.
Absolutely, and we're happy to share this stuff with you. You can always visit our website here at Bell Performance. It's wefixfuel.com or bellperformance.com, and you've got Guardian Fuel Tech there that has a lot more information. You can also feel free to email myself at dbordui@bellperformance.net or cagnew@myfuelguard.com with questions, comments, concerns, or anything related to what we've talked about today. We did plan on doing some Q&A. Unfortunately, I think we've hit our time mark. So as I said early on, we don't want to leave anything unanswered, and we will be following up directly. Thank you for everyone that submitted questions. We've got lots of them here to get to, and we will be in touch directly with follow-up. So again, appreciate your time. Thanks so much for attending, and we look forward to seeing you again real soon with the next installment of all things related to managing fuels in 2018.